Welcome to the lecture series in computer science on principles of deep learning. In today's session, we are going to focus on feed-forward neural networks, and the agenda for today's session is the definition of feed-forward neural networks, architecture and example illustration of implementation of feed-forward neural networks. Before moving on to the actual definition of feed-forward neural networks, in previous class we have discussed about a neuron, the different types of neuron and what is the role of neuron in neural networks. So, to recap, a neuron in the neural network, it consists of different layers from the input, hidden and the output, and this neuron is inspired from the biology of the human brain. So, we are going to mimic the human brain using the neural network concept. So, now we discuss different types of neural networks, and in the first and foremost is the feed-forward neural network. Here, this is one type of artificial neural network where information moves in only one direction from the input layer through the different hidden layers and finally to the output layer. So, in just this architecture is an example of a neural network architecture, and here to be in brief, we consider here x1, x2 are two input parameters, and these two input parameters have been given different weights w11, w12 and x2 if you take w21 and w22. So, these weights have been given some weighted sum of inputs through the parameters x1 and x2, equations are formed, and with the help of hidden layers some activation functions have been involved in the process. Thereby, we are moving on to the other hidden layers, hidden layer 1, 2, 3. Depending upon the input parameters and the output, the number of hidden layers and their dimensionality, the weights we are supposed to give, all those depends upon that. So, at last, to reach the target value, we will be using some activation functions as well as we calculate some loss functions. Depending upon the loss function value, if we want to improvise our output or the accuracy of the model, we just recalculate or reassign the weights and recalculate the whole process. So, this is how the feed-forward neural network works. Here, to sum up the points, we consider the input layer. They do the job of receiving the inputs and pass on them to the next layer. And here the input layer, the number of neurons in the input layer is actually depends upon or it is determined by the dimensions in the input data. And here the input is only processed in only one direction, and to note the data always flows in one direction and never it comes backward or the opposite direction. So, these are the some of the features we found in feed-forward neural network. To move on, to learn about or to know about the features of the hidden layer, here these are considered to be the computational engineering of any neural network. And here in the hidden layer, the neurons have been given some weights. We will allocate some weights and the sum of the weights is being calculated, and these have been passed to the next layer also, and we apply some activation functions. These activation functions introduce some non-linearity in the network, and we can pass on these results to the next layer. In doing so, the network can have 0 or more hidden layers. It depends upon the problem. Now, here trial and error method is used, and this method is used mainly to determine the number of neurons in the hidden layer as well as the number of hidden layers. So, to sum up the hidden layer role, we say that they are the computational engines, and depending upon the problem, we say how many neurons must and should be there in each layer and how many hidden layers will make up the accuracy of the model. Moving on to the last layer called the output layer. Here the final layer is the output layer which produces the actual output of the model from the given inputs, and these the number of neurons in the output layer also depends upon the number of possible outputs the network is designed to produce. And if you see the block diagram of this, we say that x1, x2 and so on xm are the input parameters of the any particular problem. Some weights are assigned and it goes through a series of hidden layers where the weights have been summed up and the results are produced or given to the other layers. In turn, it goes to the activation function and which introduces some linearity, non-linearity, whereby the model comes or goes to the accuracy level and at last we get the output. So, this is how what we were discussing from the last 3 classes. We were discussing about the deep learning models, and under the deep learning models we come across the word called neuron, and these neurons mimic the human brain. So, how human brain, the layers have been arranged from input, hidden and output, in the same way neural networks have been configured. Now, moving on to the different architectures, we come across all real world problems not fit into one model. So, depending upon the problem, we took the architecture of the neural networks. So, the first one is the feed forward. We just now discussed how a feed forward neural network input, hidden and output layers will be. Now, moving on to the processing steps, here if you see, at last by going through the model, either we have to assign 1 or we have to assign a -1 value. That means, whether we are considering the future as a good one or the bad one. That means, whether to sum up, whether any particular feature we are making up to the model suits the model or it is not of that particular kind. So, sequence of steps what we follow is, here we took the inputs and we enter into the layer, and these been given weights and they are multiplied through that, and these weighted input values are again summed together and to form a total, and if these values are more than a predefined threshold value, we say that okay, the output is fit, and if the sum is less than some threshold value, we say the output is not up to the mark, we can say the output is -1. And here this is an example or the processing flow steps for a single layer perceptron, which is also popularly called as a feed forward neural network model, and this is actually mainly used for the classification problems. Now, moving on to the applications, we discussed a lot about different types of deep learning models and their applications. Now, to come specifically to the feed forward neural networks, they are well versed or well applicable to the pattern recognition, classification problems, image recognition problems, time series predictions, credit scoring, cyber security and spam filtering. So, these are the different real world applications where these feed forward neural networks have been applied. Now, moving on to the challenges. So, while implementing, what are the different problems we may occur or we may face while we are applying this feed forward to any of the programming languages like Python or R, etc. Now, the first challenge is the number of hidden layers. So, to get an accuracy of the model, to have the percentage of performance above 90, 92, 95, 98 like that, it depends upon the number of hidden layers, how many we are going to take the hidden layers and number of neurons in each layer. So, what are the probable distinct feature that make up that particular model. So, we need to analyze those features and we need to think of how many neurons we can put in each layer. And then the problem of overfitting, that means again if you going for providing accuracy, that means you are giving the weights, you are changing the weights and you are applying activation functions, then we see that sometimes the data or the model might be overfit. And here the last one is the performance is very poor in case of a new data. That means, when you taking feed forward network architecture, when you apply for any other new models which are unseen, the data is not seen, that kind of model, then the performance will be very less in case of a feed forward neural networks. Now, moving on to, actually we are working with deep learning, and I already informed in previous classes that we come across from programming languages to the deep learning models, and we have seen the different stages, how we worked with the automation of computerizing a system right from programming languages to the deep learning models. From the programming languages, we make the machine to understand something, and now we are mimicking the human brain. So, in all this, here all the previous things works with the structured type of data. And now to work with unstructured data, we have to move to the deep learning models. Unstructured data means the data will be in form of images or videos or some other formatting input values. Okay. So, the very best thing is the image data set. Now, we need to understand, I have given so many pictures over here, we need to understand what a image is and how the image will be represented in any computer system. So, if you see the first picture representing an x value, we see that it is a grid of some rows and columns. So, there might be so many rows, so many columns which will depict the image of the given object. So, if you say x is an object over here, I am representing this x in form of an image. So, the cells that are there in black color are not representing the object. The cells that are there in white color, which represent a cell value of 1, will represent the particular object. So, we can very well see that the first image consists of an letter x, and similarly the second picture shows a image value of O or a 0 value. Now, see here the ones represent the object and the -1 which is in black color represents that in those positions the pixel values are not turned on. So, like this only in any computer the images will be stored in form of rows and columns. This if you understand only, we can work with image manipulations or computer visions, etc. Okay. So, now going on to the next image. Now, what we are going to deal with these deep learning models or feed forward neural networks is, we are going to identify whether a particular object in a given image is of what kind. We want to know it. Suppose I have given a, you have been given a picture and you are asked to know what is that picture is about. Suppose we do not know about that object, how can we name that? Okay. So, here if you see in this third picture, there is a set of images of cats. So, different kinds of cats in different postures, all those images will be segregated and one database is being formed over that. So, if we have some 10,000 images of cats or 20,000 images of cats, then if you upload one particular image, the system can very well verify that picture in all the angles and say whether it belongs to that particular category or not. This is what we are going to make the system to mimic the human brain and to identify the objects. So, here I have given different types of image data sets like on cat database, on clothing databases like different types of clothings where boys and girls will be wearing off like baba suits or tops or pants, t-shirts, frocks, etc. And fifth database is about the car data set. So, in order to just make the system to analyze and think whether the given object is of car or not, we need to upload some 50,000 images of car. We need to prepare in different postures how the car image will be. So, depending on that, the system will take the features from the newly uploaded object and then it compares that with the existing database and say whether it belongs to the car database or not, or the object is of car or not. Okay. So, the last one is how it takes the picture, how it gives a borderline to the object and then picks the object separately and compares with the system. So, the last figure, the sixth one represents how an object in any scenery is being tracked using the deep learning models and that particular image is being taken out to compare with the databases. So, overall in this particular slide, I am going to making you just visualize how an object being stored inside a computer system within the format or in the form of rows and columns, and why we need image data sets. We are working on a deep learning model where we are making the system to think something and analyze the object and do some performance analysis over that. So, we need the images of different angles or postures of the same object and we feel that whether the given category belongs to that image data set or not. So, after moving on or understanding the image representations and how the image data sets have been framed or come up in the real world, here I am going giving you different popular image data sets that are available publicly over the net. Okay. So, if I see the first one CIFAR-10, this is the first image data set we have and it consists of some 60,000 labeled images with 10 different classes. So, here the use case that is there is the image classification, and CIFAR 100. Here also you have some 600k of labeled images with 100 clauses. So, these are the image data sets which are being developed by or given in the public databases, where users can use that for their research purpose. And we have the Caltech 101, whereby the image size will be 300 to 200 pixel sizes with 101 classes, different categories of images have been there. Okay. And here the images of 240 to 800 images are available. So, moving on to the other popular image data sets, we have MNIST data set, where here some 70,000 labeled images are there with 10 different classes, and these data sets have the handwritten pictures of 0 to 9. So, if you want to work with any natural language processing of numbers from 1 to 9 or 0 to 9, here different patterns of style of writing 0 to 9 is being given in this data set, and with this we can use for the image classification of the handwritten scripts, digit scripts. Okay. Then if you take the ImageNet, here 15 million labeled images have been given, and it is mainly used for image classification as well as the object detection. And last one is about Pascal VOC. It consists of 11.5k labeled images with 20 different classes. So, these are the different popular public databases that are available for us to do the research. And moving on to the next phase about the example illustration. Today, learners, I am going to introduce you some form of coding whereby we can see actually how this feed-forward neural networks can be implemented with the Python libraries. Okay. So, moving on to the first example illustration, considering MNIST classification, we are taking this database which consists of some 60,000 data images are there. Here 60,000 is used for training and 10,000 is used for images, testing of images with the digits 0 to 9. So, before moving on to this, we need to first understand, I already given you an explanation of what the image data set is. Here we understood that we have a collection of some 70,000 images, that is handwritten scripts of the digits 0 to 9, in different styles it will be written off, and whenever I upload any number 5, the system has to understand that it is the 5 and it has to say me that the number is being labeled as 5. This is what the classification is. So, already there are 70,000 images, out of this 60,000 are taken for the training and 10,000 for testing. Why we are taking 10,000 for testing? We need to understand in any machine learning or deep learning models, whenever we want to work or we need to find out the prediction accuracy, we can't go for any new things, right. We already have scriptures that have been written. So, in the given data itself, we will divide it into testing data and the training data. So, we will use the training data, we will build the model, and by applying it to the our model, whatever the feature we would like to introduce, the networking model, after applying that we will get the output. So, we will compare that output with the already existing 10,000 test images. So, if what we got and what is there actually matches, by that we will get the accuracy of the model. So, in doing so, what are the steps that are involved for this is, first one is you need to load the pre-built data set. The publicly available data sets has to be first loaded. Okay. And by loading here means we are going to use the Python libraries. TensorFlow and Keras are the libraries that are used for building any of the deep learning models. So, here we need to take the public data set, we need to download it into our Colab workspace we can work on if you want to work online, and we have to tell which type of neural network we are going to build with that image data set, and we need to train it actually, and then we have to evaluate the accuracy of the model. So, these 4 are the basic steps for us in any of the deep learning models. So, to start with, here how to load the data set now. Now, here the understanding is, till now we are learning the theoretical concepts, okay. But when we practically do only, we can understand these deep learning models how they will work. So, we are moving on to the coding now. Now, here instead of just writing over the coding, I mean presenting the coding, whereby what are the different libraries that are used and what is the function of each function to just call out the built-in function and to work with the image data set. Now, see here the first two steps are the importing libraries. So, in any of the programming languages, if you see from the starting C, C++, Java, there might be header files or there might be some libraries which we have to import as part of the programming. So, the definitions of these functions will be there already in those libraries. So, we are calling or using those libraries in Python called TensorFlow STF and NumPy as MP. And here see here MNIST is a variable whereby we are calling under the Keras data sets MNIST. So, these are the built-in data sets or which are publicly available, those will be downloaded here. Now, here we have a function called load data. That particular function will load the publicly available database into our training and testing data. So, x and y we have the images sets. So, we are taking the training of x and y and we are taking the testing of x and y. So, these have been loaded. Now, here we say that images of the pixel size is 255. So, those training and testing data images thing is being taken into the x train and the x test. Okay. Now, moving on to the second one. So, after loading the data, what we have to do is we need to build the model. So, here in doing so, we need to know certain glossary of the terms. So, after understanding the glossary of the terms, we can move on to this particular function actually. See here, these are the glossary of the terms which we have to understand. See here, the words are epoch, rectilinear unit, cross entropy and Adam optimizer. So, these are the 4 buzzwords which there might be inside the coding. We will be using these functions, predefined functions that are already there in Python library as part of our coding. So, to understand the epoch, it means one complete pass of the training data set and it goes through the algorithm. So, one complete pass, if it is over, we call it as an epoch. And here there are, I informed you, so many activation functions are there, and these activation functions are not yet detailedly discussed in our sessions. In forthcoming sessions, we will be dealing with these activation functions. Now, to start with, we are just using in our coding the rectilinear unit called ReLU function, and this actually introduces some non-linearity to the model and whereby it solves the vanishing gradient issues. Okay. So, this one more thing is the cross entropy which we are using as part of the coding, and we call it as a logarithmic function, loss function, and this is mainly used to measure the performance of our classification models. So, when we use this built-in functions, it calculates the error function or log function and says us how far it is the system is performing. And last one is the optimizer function, that is Adam optimizer, whereby it is an estimation and it is an optimization technique for the gradient descendant. Okay. So, after getting an idea of all these things, now we are moving on to our example. This here we first loaded the data set. Now, we are building the model. Now, here our deep understanding of the focus is tf.keras.models.sequential. We are calling a function, sequential function, which is the feed forward neural network, and within that we are defining some of the layers, and these layers we are saying the shape of the image is 28,28, and we are calling the activation function called ReLU, and we are adding different layers to the given function. Now, moving on to the actual, what we are going to do is, in building the model, the first thing is we need to take the model and we need to calculate the entropy, and that is we are calculating the loss function. After calculating the loss function, we are using the optimizer called Adam, and these are all the built-in functions that are already available in the Python library. So, each and every time when you are working with, you can keep on changing these values and check the accuracy of the model. So, we are compiling the model with these parameters. So, see, our function consists of 3 parameters now. One is to set the optimizer, the other one is to set the loss function, and the third one is so which type of accuracy model you are going to use. We are saying accuracy is the metrics we are going to use for this model. Now, we are going to fit the model with the training data, x and y training data, and we are making the epos as 5. So, 5 full times we are making the system to run, and here we are evaluating the model with the verbose of 2. So, and in the entire coding of this we understood that first we need to take the model. After taking the model, we are calculating the loss function using the built in function and we are compiling our model. After compiling the model, we are fitting the data for 5 epochs and then we are evaluating the model. So, these are the 5 steps that are involved to get executed with the feed forward neural networks. So, if you run this code, you will get the outputs like this: epoch 1, epoch 2, epoch 3, epoch 4 and epoch 5. At the last, we got an accuracy of 78%. Usually, our accuracy should be more than 85 or 88 or 90 will be a better one. So, as the accuracy is not of that much when you choose the things, here there are one more function called the dropouts. Dropout is you are taking the images and certain images make some noise, we want to leave that. Okay. So, in doing so, we are taking the dropout as 0.2 and when you apply that particular dropout function to your model, then the accuracy is now been increased. Now, you got an accuracy of 96%. So, from the beginning we understood that we are loading the data set and we are applying the basic functionality from the Python library, all the built in functions. In doing so, we are calculating the loss, we are applying the optimizer and we are applying the metrics of accuracy. So, after compiling and then fitting the model, we are evaluating the model. So, these are the steps which makes us understood how we have to just evaluate any particular image. When you take in a database of 70,000 images, 60,000 are training and 10,000 are for testing you kept. Now, you can check that how these 10,000 images have been evaluated, whether what is their accuracy percentage. So, in doing so, we got the 96% of the accuracy. So, now moving on to the illustration example of 2, where the same thing we have taken with the fashion database. So, the first one is of the digit database. Now, the second thing we have taken the example is the fashion data set. Here in this fashion data set, there are 70,000 images which are in black and white of different categories of the clothing data set. Now, again the same thing, we are going to load the data set, we are going to build a model, train the neural network and evaluate its accuracy. The same, one and the same. Now, why I am giving two types of explanations of or illustrations is how you will work with the first data set is a very simple feed forward network. Here is somewhat different categories have been included. Instead of one category, we have been included different categories. See here the class names are either it can be a t-shirt or a trouser or a dress or a coat or a shirt or a bag or an ankle boot, etc. So, these are the different labels that are available inside the data sets. Now, as usual for any of the programming, we have to while building the model, we have to take the TensorFlow and NumPy and we are going to see visually how the images are, how the labeling are. So, to understand the data set, we call the matplotlib graphic library and we have loaded the first data set. So, what is the function that is used in Python to load the data set is load underscore data. So, in doing so, we are taking a variable called fashion underscore MNIST and here Keras data set fashion MNIST is being called and we are taking the training images as well as the training labels. So, each image has a label over here. So, those labels are also being taken. So, we categorize it as training data set as well as the testing data set and we are loading the data. After this, we need to just visually see one particular image. Through this matplotlib functions, we can understand how the image of a ankle boot will be. So, see here we are taking a plot function, we are taking a figure and we are taking the training images of 0th one and we are using a grid to show that how the particular ankle boot represents, how what type of image is there in the data set. After viewing visually what an image is, now here we are moving on to the actual coding of the model. See here the different images are there, testing data and the training data and we are trying to depict or print all the images. Now, see here for each of the images we are calling the label function and we are showing what all the different types of labels that are available. So, these are the different data labels that are available. See here different types of shirts, ankle boots, frocks, pants, t-shirts that are available. So, after just visualizing all these things, we are moving on to the coding structure now, how to implement this and how to frame the model using the Python libraries. Now, see here, this is the overall coding, and here in the code we are taking the model, we are compiling the model, and then we are fitting the model and we are evaluating the function. So, these steps have been detailedly explained over here now. So, we are calling the sequential function, and here we are using the input shape of 28, 28, where which represents the image grid structure, and here we are taking the ReLU function, which is an activation function to introduce the non-linearity, and here we are taking the dense layers as the 10 value. Now, moving on to the next set of coding, we have to compile the model. For compilation, we need an optimizer and we need to calculate the loss function. So, in our first example, we are taking the optimizer as Adam optimizer and the loss function we are taking as the cross entropy, and accuracy metrics we are just assuming the input value further. Now, while fitting the data, we need to fit the training images and labels with an epoch of 10. So, in this problem, if you run for 10 epochs only, you will get the accuracy. Okay. In previous example, we have taken the epochs of 5. So, while you are executing, taking these as an example, if you want to know the difference between each of the executions, you can give the epoch, you can change the values as epoch f3 value or 10 or 15 or 20 also you can have, which makes the system to move. It will take a little more time to just process that. Okay. So, you can change the epoch values according to your problem and see the difference. If you got a very good accuracy level, you can fix up your epoch values. Now, at the last we calculated the loss function, we have evaluated the model, and we are printing the accuracy. Now, see here, when you execute this, we have done for 313 out of 313 and you have a step accuracy. Here you got the percentage as 88.6. So, by this way we can implement the feed forward network for any of the publicly available data set. So, in this session we understood that how a feed forward neural network is used for real applications, how we can implement this in using the Python libraries using TensorFlow and Keras, and how to build a model. And after building a model, in order to improve the accuracy of the model, there are various steps or various points whereby you can either change the activation function or epoch values, or you can either give the optimizing Adam optimizers, etc. These all you can change and you can improve your accuracy. So, to know about these concepts, these are the different questions. What is feed forward networks, what is its architecture, and what are the different libraries that are available in Python to implement this network, and its uses, and what are the different processing steps in doing or building this model using the image data sets. So, that is all for this today's session. Thank you.